Good morning. My name is Shaohui, and I am representing CICT Mobile Communication Technology. It's a great pleasure for me to participate in this workshop and to have the opportunity to share the latest advancements in 6G research in China with experts from across the globe. Mobile communication systems has evolved through the generation every 10 years, with 6G anticipated to reach the commercialized around 2030. The development of 6G can be brought into three phases. First, from 2020 to 2024 marks the phase of the concept formation and key technology advancement. During this period, a global consensus on the technology trends, along with a vision for the 6G, is expected to be established within the ITO. The subsequent phase, spanning from the 2025 to 2029, focuses on the international standardization. In this critical stage, the 3GPP will serve as the global platform for formulating the technology framework and the architecture of 6G. This effort aims to define a unified global standard for 6G. In the final phase, the primary objective is to enhance the maturity of 6G industry R&D, thereby supporting the commercialization process of 6G technology. In China, Ministry of Industry and Information Technology, MIIT, and Ministry of the Science and Technology, MOST, have initiated 6G research and development projects in 2019. The IMT-2030 Promotion Group was established, uniting the forces from the industry, academy, and the research institute to advance 6G research across various domains. These domains include the vision and the requirement, spectrum, wireless and network technology, standardization, trials, and international cooperations. Currently, the IMT 2030 Promotion Group has more than 100 members and welcomes participation from the global companies, such as Ericsson, Nokia, Docomo, Samsung, and Qualcomm. This collaborative effort underscored a commitment to fostering global partnership and innovation in the development of 6G technology. China actively supports ITO endeavor to cultivate a unified vision for 6G technology. Through the collaborative effort worldwide, the ITO approved the framework and overall objectives of the future development of IMT for 2030 and beyond in June 2023. This document lays the foundational groundwork for the global development of 6G. The ITO has identified 6 usage scenarios for 6G. 3 these scenarios are extension of 5G capability. Additionally, 3 new usage scenarios has been introduced in the ITO's 6G vision framework. Integrate sensing and communication, AI and communication, and connectivity. These scenarios blend both force new capability, such as sensing-related functions and application AI technologies, to assess the performance of these innovative services. The 6G network is evolving into a mobile information network. poised to support a wide range of services that expand both the connection and beyond the connection function. It includes 9 typical use cases, which can be distilled into 3 distinct features: immersive, intelligent, and ubiquitous. In alignment with these features, 6G is characterized by the ubiquitous connectivity, universal intelligent, multi-dimensional sensing, seamless coverage, security, and trust, and a green and low carbon footprint. Through this advancement, 6G aims to get to the variety of the scenarios, harnessing diverse capabilities and fostering and integration of the innovation across communication, information, big data, AI, and other technologies. It supports the development of light and distributed networks, paving the way for future that are environment, abilities, and interests for security. The 6G network is evolved into a mobile. As a crucial initiative, the IMT-2030 Promotion Group has undertaken research on the 6G use case and the performance requirement, providing essential support and strategy direction for the advancement of 6G technology research. These presentations outline the stage and the various dimensions of the requirement research, include the vision, scenario, key capabilities, use cases, technical performance requirement, and other related activities. Currently, the focus is on investigating the typical 6G use case and their technical performance requirement. Taking the 6G AI as a services, AIS, as an illustrative example, the research group has analyzed AIS requirement across different scenarios and identified typical applications. For this analysis, the group has defined AIS within context of 6G, along with its key performance indicators. In the slide 6, regarding the 6G spectrum, the research is focused on the understanding the demand for the 6G spectrum, exploring propagation characteristics at millimeter wave and terahertz frequencies, and investigating the new technologies for spectrum utilization. Given the diverse range of 6G use cases, it is evident that 6G will access to the low, the medium, and high frequency band to meet its comprehensive requirements. Specific frequency band below the 15 and 44 GHz is anticipated to play the central role in the 6G infrastructure. Furthermore, last year, China took a leading role in allocating the 6 GHz frequency band for the advancement and the implementation of 5G and 6G systems. This initiative underscored China's proactive stance in the fostering the development of next-generation wireless communication technology. Next slides, page 7. Here I will share some comprehensive insight into the future of the 6G system from China. 6G network is set to operate across the broad spectrum range for sub-6 GHz to the terahertz frequency. It's to enable the intelligent connectivity of everything across the various indoor and outdoor scenarios and achieve the global coverage. Integrating the terrestrial and the space networks. The 6G is anticipated to support the multi-band RAN, facilitate the multi-access technology and enable flexible network, ensure the on-demand orchestration and consistent services delivery. Then we go to slide 8. IMT-2030 Promotion Group established the test group for the critical area. The wireless technology include key area, the air interface evolution technology, and radio technology, low spectrum technology, integration technology, wireless system design, channel measurement and modeling, and the non-terrestrial network. The slide outlined the research area within the network technologies, highlighting the network architecture, network security, and the 6 specific research directions. These 6 focused points include space, air, ground integrated networks, air native networks, determinist network working, computing-aware networks, information-centric networks, and digital twin networks. Regarding the network technologies, science report has been published in China, showing the process and the finding in this innovative field. Let's go to slide 10. IMT-2030 Promotion Group is carrying out 6G technology trials to foster technology vision and build a wide consensus. This trial structured into the 3 distinct phases: key technology trial, technology scheme trial, and the system trial. Trials were both for the wireless technology and 3D network technology has been demonstrated in 2023. This includes terahertz communication, integrated reconfigurable intelligence services, RIS, and wireless AI distributed autonomous networks, computing-aware networks, and data services. This comprehensive approach ensured through the evaluation and advancement of the 6G technology. Let's go to first slide, number 11. The development of 6G technology is at a pivotal stage globally to ensure its scalable growth. Here, highlighting the several key considerations for the advanced 6G development. First, there is a need to delve deeper into research on the crucial technology and enhance the design of system schemes. Second, the continued organization of 6G technology trials is vital and is accelerated the path to industry maturity of 6G technology. Thirdly, enhancing 6G spectrum planning and ensuring the availability of spectrum resources are critical steps. Collaborative efforts are essential to foster consensus on the harmonization of the 6G spectrum on a global scale. Finally, upholding the pivotal role of the international standardization bodies such as ITU and 3GPP is crucial. Involvement promotes the establishment of the globally unified international standards, laying a solid foundation for the worldwide adoption of 6G technology. Okay, that's all my presentation. Thank you for your attention.